Right, so find the area enclosed by these two graphs. So we're going to draw a picture so we can see, what the intersections are and which one is the upper graph and which one is the lower graph. So I'm going to graph the parabola first because that's the more complicated graph. I always just start with plugging in 0. Just plug in some little numbers and see what you get. If you don't have a calculator, that's what you've got to do. So if you plug in 0 for x, you're going to get 3. And if you plug in 1, this will be 1 minus 3 will be negative 2 plus 3 would be 1. So 1, 1. If we plug in 2, that'll be 4 minus 6. So negative 2 plus 3. So again, 1. So this is where the graph's going to turn around, is somewhere in between there and then come back up. So I'm going to have this symmetric point 3, 3 over here. So our parabola is going to do something like that. It's good enough. We're just trying to see where the intersections are and which is the upper and which is the lower graph. The other one was y equals x. So that's going to go through the origin and have a slope of 1. And so this is the area that we are trying to find. So we are going to integrate from here to here. Now looking at our x values, that's going to be from 1 until 3. So we're going to integrate from 1 to 3. And it's upper graph minus lower graph. So the line is above the parabola. So it's going to be x minus this x squared minus 3x plus 3 equation. So we're going to need to distribute the negative through there. So this will be x minus x squared. Oh, whoops, I put an extra squared in there. I'm sorry. Oh my gosh, and I made that a 3. 3 is everywhere in this problem because it was from 1 to 3. We start over. X minus x squared, there we go, plus 3x minus 3 dx. And then I'm going to combine the x's together. I have x plus 3x, so that is going to be 4x. All right, so I've simplified that down. Now I'm going to do the antiderivative, and then it's upper boundary minus lower boundary. So this will be negative 1/3 x cubed plus 2x squared minus 3x, such that from 1 to 3, and then upper boundary minus lower boundary. So if we plug in 3, 3 cubed is 27, a third of that will be 9. So this is negative 9 plus 3 squared is 9, double that is 18, and then minus 3 times 3 is 9. And then if you plug in 1, this is going to be negative a third plus 2 minus 3. And this first part ends up going to 0. We have 18 and then minus 9 minus 9. So that's like all gone. I'm just going to distribute this negative through here. So we'll have 1/3 minus 2 plus 3. And so these will combine together to just be 1. So we have 1 1/3, which is 4/3. So 4/3 for your final answer. So that one is C. Right, number 2, if C is in between 0 and 1. So when we go to graph this, C is going to be in between 0 and 1. We want the region of area enclosed by the graphs of y equals 0. So that's just the x-axis. The rational graph 1 over x. So that's this, hourglass looking graph. We're not going to end up meeting the arm of it that's down here. We're going to just be in the first quadrant, but just to be thorough, I'm drawing the whole thing. X equals C, so vertical line here, and then x equals 1, so vertical line here. So this is the area that we are finding. So it is going to be the integral from C to 1. And then it's upper graph minus lower graph, but the lower graph is the x-axis. That's just 0. It would be minus 0. So it's 1 over x minus nothing. So just dx. So antiderivative. Hey guys, what is the antiderivative for 1 over x? I have to throw questions at you that you're actually able to type in the chat. So I'll throw you guys that one. Antiderivative for 1 over x. What is that going to give us? Make sure everyone's awake here with me. Good, nice job, guys. ln, perfect. Sweet, thank you. All right, ln of x, and such that from C to 1, and so we're going to do upper boundary minus lower boundary. So it's ln of 1 minus ln of c. Now, I like this problem up until this point. Here's where I have an issue with it. I'm going to work this out the way I think they should have done it. And then we'll work it out how they did. I don't like how they wrote the answers here. I take issue with that. Because what is ln of 1, guys? Here's another one that I can ask you. What's ln of 1? Because that's one that we should know. Like, what is that going to just end up being? Good. That's 0. So, like, in my opinion, the answer to this question should have been negative ln of c. Like, that should have been the answer, because this ends up being nothing. But you'll notice that's not a choice. Positive ln of c is a choice. That's extra tricky. But what they did is they used the log property. And every time I bring up log properties in calculus, everyone just stares at me. You did learn them in pre-calc. I know it's not like something you walk around remembering all the time. But when you're adding, you can multiply what's in the logarithms. When you're subtracting, you can divide. So since this is subtraction, they just divided 1 divided by c. So ln of 1 divided by c. So this one is B. I like that question right up until the very last step and how they wrote the answer. I feel like it should have been like that because that makes a little bit more sense. Alas, no one asked my opinion. All right, number 3, this one's no work. We just have to pick which one of these is the correct setup. So we want to integrate from A right here until C, which is right here. So we want integral from A to C, and then upper graph minus lower graph. The upper graph is f of x, the lower graph is g of x. So we want integral from A to C, f of x minus g of x dx. So this one is D. I like that one. We didn't have to even write anything down for that. All right, number 4, the area of the region between this graph and the x-axis. It's nice when one of them is the x-axis, because that's just nothing. You can almost sort of ignore that. We don't even need to draw a picture for this one. They give us the boundaries and everything from 1 to 2. We're going to do integral from 1 to 2 of this function. So antiderivative is x to the 4th plus 2x, such that 1 to 2, upper boundary minus lower boundary. So if we plug in 2 to the 4th will be 16, plus 2 times 2 is 4. You plug in 1, you get 1 plus 2. So this is 20 minus 3, so 17 for that one. So D. All right, number 5. What is the area between the graphs of y equals x squared and y equals negative x from 0 to 2? All right, I'll draw a picture of this again just to be thorough. You can probably kind of visualize this one. I'm only going to draw it from 0 to 2 because those are going to be our boundaries. Again, it's nice when they hand those to you from 0 to 2. X squared is going to be a parabola. I'm just going to draw like this half of it. And y equals negative x. It's a line that's going to go through the origin and have a slope of -1. Again, both these graphs would keep going over here. The parabola would do that and the line would keep going, but we only need this from 0 to 2. So this is the area that we are looking for. And so we're going to integrate from 0 to 2, upper graph minus lower graph. So that's x squared minus negative x. So those negatives are going to cancel. It'll be plus x. So I still subtracted. It's just, it was minus negative x. So the negatives canceled out. So antiderivative 1/3 x cubed plus 1/2 x squared from 0 to 2. Upper boundary minus lower boundary. So plugging in 2, this will be 8/3 plus, all right, 2 squared is 4, half of that is 2. And then if you plug in 0 to all this, you're just going to get 0. So I need a common denominator to add these together. It would be thirds. 2 would be 6/3. 6 divided by 3 gives you 2. And so this is 14/3. So D for that one. And then last one, what is the area of the region in the first quadrant? And that's always nice when they just restrict you to the first quadrant. You don't have to worry about the rest of the graphs. Oh, they even tell us we're not going to even have to graph this one because they tell us on the left by this graph and on the right by this graph. And they give us the boundaries. Y is from 1 to 3. This problem is really kind. The only reason you need to draw a graph is to get these intersections, to get your boundaries and know which is the right and which is the left, or if it's upper minus lower. They literally tell it to you in this one. And both the equations are already x equals. We have x equals y squared and x equals 4y minus 3. So they told us everything. This one was great, right? Now it is a dy problem. So we're going to go from 1 to 3. Those are y values. Y is 1 to 3. And then right graph minus left graph. So they tell us the right graph is this 4y minus 3. Minus the left graph is y squared and then dy. So these are y values. Everything in here says y, and then it's dy. You need to make it uniform. Like it all needs to, you can't mix and match your variables. You can't have x's and y's mixed together. All right, so antiderivative, this is 2y squared minus 3y minus 1/3 y cubed. We're going to evaluate from 1 to 3. So plugging in 3, 3 squared is 9, double that is 18. 3 times 3 is 9. And then 3 cubed is 27, 1/3 of that is 9. So again, that all goes to 0. 18 minus 9 minus 9, that's going to be nothing. And then if we plug in 1, we're going to get 2 minus 3 minus 1/3. I'm going to distribute the negative. And so this ends up the same as that other problem that we did. -2 plus 3 combines to be 1, and then plus 1/3. So 1 1/3, which is 4/3. So that one is A.